Hello, everyone. How are you guys doing?
Good, how are you?
Good, good, good. All right. Yeah. So welcome to the new class, new session. Today we're gonna discuss a system design case study. Uh, it's designing Instagram actually. It's one of the famous case studies, famous question asked in many interviews. Um, so we can start. I think we have enough people, and people can join later on too. Um, so let's actually get this thing started right away. I can show you what we're gonna discuss. At a high level, we're gonna see the requirement section, the function, non-functional. Then we'll have the high level design of the system. Then we'll discuss the database schema. Um, we'll discuss about these.
मम्मा मम्मा हाथी दर्द हो गया नहीं
I can you mute? Okay. Uh, um, then we'll discuss in detail the overall system design of the system, and then there'll be like further discussion around it. So that's the overall actually the discussion we're gonna have today in like 1.5 hour of session. All right, can you guys see this properly? It's enough big, I guess.
Yeah, I can see it.
Yeah.
Yep.
All right, cool. So let's get started. We can actually go through these initial parts pretty quickly because they are simple and they're quite similar to what we discussed in the master what we call it, the master template. So designing Instagram is over there we discuss the system YouTube. You can say Instagram is similar to YouTube. It's again social media. It's a read heavy system, and over there, okay, there were bigger videos and streaming is going on. Over here, we have generally photos and smaller videos. So functionality wise, if you see the functional requirements, the topmost requirement is users should be able to upload and view their photos and videos. Okay, this is the first requirement. The second is user can follow each other, right? One user can follow other. You can follow as many as you like. So which means like people can have millions of followers, right? As it true with Instagram. This requirement is quite important, that there's a news feed, or you can say I have this home screen where I see the top posts from the people that I follow. Okay. This does not cover everything, but of course, okay, this is just at a high level. It covers bigger requirements of say Instagram, and even like all others. So Karthik, can you mute or I can mute it? Oh yeah. Okay, cool. All right, yeah. So yeah, if you see these requirements, the function requirements, you'll see most of the uh, social media, they have these requirements. If you see Twitter, they have similar thing. Instagram is there, or Facebook is like that, or even YouTube as well. You subscribe to these channels and you see the posts in your news feed kind of thing. So or Reddit, or anything, Quora, all these, they have similar things. So we just gonna discuss one question and try to cover as many aspects as possible. Or if you guys have any specific question, dig deeper, we can actually dig deeper in certain scenario. So most crucial point probably is the newsfeed generation. Otherwise, it's a simple storage, efficient storage, quick storage, and having a high availability of the system. That is the main thing required. Non-functional, again, as I mentioned, the system needs to go on the availability path as compared to the consistency path, right? So availability means, okay, system is mostly available. Although consistency wise, if I see post and then I don't see a post, that is a consistency issue, right? So we might get a hit over there in CAP theorem's term again. So we will choose the availability path. If a post is, for example, created and it's not shown to the all the relevant users right away, it's okay, because it will eventually be shown, like the way eventual consistency work. Reliability over here means people upload their photos, videos, and the post. That data should not be lost. Whatever is stored over there, even it's 2 years old, 3 years old, multiple year old data, it's there. I can go and check and see. That's generally true with all the social media. Yeah, so these are pretty much those, but they can be other non-functional requirement. You can say scalability. I did not write over here, but I mean, it's quite obvious. It's a very big system. It needs to be scalable. What else? Like there can be other things, for example, security wise and other stuff as well. But generally you can say availability, consistency, and reliability are the general ones that we always try to incorporate in our design. This could be the high level. It's again those 5-6 blocks that you can always draw to give a high level idea, right? We client this Instagram, you can say system, which needs a database to store the metadata about the post, the photos. Then we have the actual photo and video storage, like a blob storage, like S3 or any in-house. Instagram has like, definitely they're so big they cannot use an external cloud storage. They have to build their own, because otherwise it's very costly, and not easily, flexibility wise. They have to own their own system so that they can be very flexible with the storage. Then of course, let's say feed generation is an important component. So we'll see that, okay, there's this service feed generation which talks to the metadata only, and from the metadata it actually generates the feed and also store it in the database that can be returned to the server, to the client. Yeah, so these are high level components. Some people try to put like load balancers here too in their first try. That is okay too. Caching can always be there. So there are these fixed components, API gateway, if you want to put it generally, I would recommend that over here you actually go with the core functional components as compared to all these peripheral components. They're always there, and we can always draw when we move on. Any questions so far, or was it's all okay, I guess? All right, let's discuss the schema in the database. So the two big entities, user and the post, right? If at a high level, you can say, if you extend this thing, you can say, okay, each post has comments as well. So that comment thing can be added to further extend this schema. User wise, let's discuss each of these tables. User, we have the name, email kind of thing, the last login. Main is the user ID, and then they have other stuff. Similarly, post has a post ID, a unique ID, then user ID, that who's the owner of the post. Photo URL, it's like that external URL where the actual photo or the video is stored. It could be an S3 kind of thing, an external system, and this could be the whole URL or the path or the sub path of the storage where you have actually stored the photo. The post text, this is the text, and photo location, you can say creation time. You can have more things over here. With Instagram, they have these tags. Tags are everywhere in all social media. So you can have tags, and then those tags are used for like searching, or even it's like a bigger channel. Let's say if I have a post and it's related to system design, so I can actually just see the post of system design from all the users in the word, so that system design is kind of a user, you can say. And so all the posts that are created by different users, but they have tagged their posts on this tag line. You can use the tag over here. I've not put it here, but those are the two, like comment section and the tagging section. Probably it could come into like discussion in the overall design. We have this user follow, of course, the follower and follow ID. Again, yeah, there's this follower and they can have multiple following. So this is just a you can say two IDs just to have that many to many relationship. Any user can have many followers, and every follower can be the follower. It could be one to many or many to many. I don't know. Many to many. There's a user. It's a self. The relationship with the same table. One user can have many followers, and that follower can have many other followers. I don't know. We call it many to many, but anyway. So this table is actually giving us the complete list of followers of any person, any user. The other discussion comes over here is SQL or NoSQL. So actually, since I worked at Facebook, I know Facebook actually stored this data in MySQL, which is a relational database, but they might have their reasons, legacy reasons, because if you design it today, you might go with the NoSQL database, or part of this database could go into the actually NoSQL database. Although we have relationships, for example, user and user follower, and these relationship is actually pushing us to either use the relational database, but even a NoSQL database can have this thing. For example, each user, we can have a list because it's a like a document, a MongoDB kind of thing. Each user has a list of all the followers over there. So that we don't have to fetch it, go over there, and actually, go in the other table and get all the followers of this person. Whereas if it's already there in MongoDB kind of in a document, we have a list of all the users that are the followers. But over there, then filtering and those things become tricky, because you have a list of users, and you have to bring it to the application side and filter over there. If somehow you need to filter users, that could be tricky. So overall, this high frequency things, generally people go with high frequency updates of data. They go with NoSQL database. We haven't discussed like a post has likes, or you can say number of shares, like a LinkedIn post. So we can actually have those counter variables in a NoSQL, which is very optimized, you can say, for frequent updates of a data. Yeah. What else we can discuss here? So overall, because of the relationship, we might go with the SQL databases, but keeping the scalability requirements in mind, we can actually do all this thing in NoSQL, or even at least the part of it that can go in the NoSQL too. Any question over here? Because it's not very comprehensive. I touched upon a few things, but I mean, yeah, this is enough for the discussion, and we will keep expanding.
For like the user ID or post ID, why would we use an integer, not like a UUID? Or does it really matter?
Yeah, that's a very interesting question. It could. I mean, yeah. How can we answer this thing? So, like, it can be anything, right? As you said, like, it depends, like, what are we going to achieve? It's generally a UID, you can say, but an integer number could be there. As I remember in Facebook, they were having a number actually, which is not a UID, UUID. UUID was, as I remember, it was very expensive to generate. Like it's a very small thing, as you see, but if you are generating millions of them for like each post or each comment to make them unique, then it becomes quite tricky. So they ended up actually, all these big companies, Google, Facebook, they have this ID generation system, which just creates unique IDs. Either it could be, it could be a UID, or it could be a lot more sophisticated. Like for example, if for post, if you need recent posts a lot, when you are optimizing your read queries, then you have to actually come back over here and optimize a lot of stuff. For example, if I need my recent posts of many users, like most of the posts that you see on your news feed, those are the recent posts of the users that you follow. So recency is a thing. So this means, oh, I need to fetch this data probably based on recency a lot more time as compared to random access. So for that, let's say if you want to create an index on creation date, which is the last column over here. So primary index would be, of course, the post ID and then this thing. So that indexing become tricky. So you need to optimize queries, and based on your query pattern, you have to either update your schema or update your indices that you create on this table. Yeah, and it becomes tricky like with SQL, because schema alteration is not easy over there. NoSQL, you can add or remove columns easily, but then they have their own challenges with especially secondary indexes. MongoDB, as I remember now, started giving over there. So again, I think to answer your question, it could be a UID. UID has its disadvantages though. Although it's unique, mostly unique, like 99.99%, it can have duplicates. And then generating it is very costly operation, especially when you are generating millions of UIDs. So an integer or a big integer kind of thing, based on how much users or posts you can expect, you can actually come up with a number. But that's a good question, actually.
Makes sense. Thanks for that.
It's yeah, we'll probably discuss something when, especially the thing I mentioned, the recency, how to actually change the ID in such a way that the recency is easily like indexable, you know. So because as you understand, right, so you can have multiple indexes on the table, but each index that you create, of course, makes some read part faster, but it makes your write path slower, because then you have to every index is a layout of data, right? So you have to for every index you have to define another layout and write over there too. So writes eventually become slower. But we'll discuss a little bit.
Hey, Arsan.
Yeah.
So I have a question regarding the password on the user table. So like during the basically during the system design interview, is it expected to, for example, go into or basically describing how the password can be like hashed, because in terms of like not storing the actual password in the table, but like how to, like, is that expected, or is that more on the if they ask you?
Yeah, more they are if they ask it, and they'll never ask unless it's a security interview, related interview. Password is just a put, and I just put it over there. So remember, so you are building a system over here which never said about anything about, you know, security wise, you can say. Authentication or authorization is the crucial part, but over here we did not mention them. So just putting this varchar 32 does not really mean anything. If you really want to, if you understand how, for example, passwords are stored and how they are encrypted or salted or whatever, all those technologies, and then sometime even the password authentication part is altogether separate, and they're not even stored with user ID or something like in the main database, you know. So I just put it over here just for the reference, and they will never actually they will hardly they'll discuss this thing. So but since it's a crucial, authentication authorization is you know, it's one of those like API gateway kind of things. So you either you have worked with it with API gateways or authorization, or you have not, or most of the people have not. They're actually working on, because all these systems are already built and we just plug them with our system and use them. Authentication, authorization, or API gateway, and then we just have to configure a little bit based on certain requirements. So do read about them though, because then you get, okay, some understanding. Okay, yeah, okay, these are the, for example, the password, the authentication mechanism, and these are the authorizations. Let's say, for example, authorization is also handled by the API gateway. So what mechanisms are used over there, and then how do it ensures that every request that it is forwarding to a microservice is authorized. So that kind of workflow is very like interesting to know. It's again, it's only specialized use case and will be asked to specialized user. For a journalist interview, they would hardly go over there unless there is a solid reason.
Gotcha. Thanks.
Yeah. Photo storage, as I said, we can actually do anything, actually, both of them. The file storage, as I said, like HDFS, and then we can have S3 kind of object storage. Every cloud has, Azure has the blob storage, and my Google Cloud has too. It's that kind of thing. In Facebook, if I remember, they were having HDFS originally, but then they rewrote on the system, and that system, the file storage system, has different variations. Because they're going to store videos, bigger, you know, video files, smaller files. They actually bunch together a lot of smaller files, the photos in one piece, and then store it. It's they were using HBase kind of system. But over here you can say it's just the storage thing that you use it like an S3 kind of storage where the photo is stored, and you have a URL, and that URL is used to access that.
Hi,
Yeah.
Ashan. I have a question. I understand that like distributed file storage is used usually if you want to store data from multiple locations. Is there any other reasons or justifications as to why a distributed file storage should be used over an ordinary file storage system?
Yeah. So yeah, like, okay, what do you mean by ordinary file storage system? Oh, the normal that we have on our PCs, huh? That's what you
Yes,
say?
yes,
Okay.
yes, like a normal file system, yes.
Yeah. So so what happens that, let's say you have a video, you have YouTube, so you have bigger video, 2 hours, 3 hours video. So what happens that you don't want to store that video in one computer, one server, one node, okay? Because there are many reasons why you want to make it distributed. Because, okay, if that server is down, that whole video is gone, right? So you want to make multiple copies of it, let's say, at a high level. Okay, now these days no one makes a copy. They have gone a lot fancier. So what happens, you actually divide that file into smaller chunks and then store those chunks into multiple servers. What benefit you get when you are uploading a video, instead of just taking that video from the client and storing it one server, is slower as compared to you can have multiple chunks to it, and all those chunks are being stored in parallel. So it's just most like a torrent kind of a thing, right? So in torrent, you are downloading something from so many things and so many other servers, other users that are sharing that file, and you have chunks and you are downloading in parallel. So again, storage become faster, and then of course retrieval become faster as well. And then the main idea is of course the availability, but then the reliability. So what happens that, as I said, you have to make multiple copies of it, copies of a data, and to have a redundancy in the system, so that if something goes down, you can get it from the other server. So they do, so you can make like simple copies of that data, or you can use the Roger encoding or the Reed-Solomon kind of encoding. So they actually tell you, they devise these algorithms where that you take a file and they divide it into multiple chunks, and then they say, oh, just make copies of all chunks. That is how using Zoring and fancy algorithms, and instead of like one storage, if you make a copy of like 1 GB file, 2 more copies, then you get 3 GBs, right? 2 more copies, 3 GB overall storage. But with the Roger encoding stuff, you take 1 GB and you only take half GB of the data that you calculate somehow from these blocks, and that 1.5 GB gives you actually 3x or even 7x or 9x of storage. That is how like mathematically they have devised. So overall, the answer is distributed storage for high availability and reliability, and of course the throughput or the latency, you can say. All to improve all these things, you need a distributed file storage. Otherwise, you have a single point of failure, and that won't work.
Okay, got it. Thank you.
Yeah. Add new post to all followers based on the recommendation from feed generation engine. Like, yeah, this is a very high level definition. We'll go through actually it. So feed generation is actually, I'm following these many people and I wanted to see the latest post or the posts that are very gone, very famous or very hot. And that's the idea of the news feed. This is overall the overall system. Let's see. Let's quickly go through it, and then we can dig deeper into some parts. One is, of course, the client, and there's this load balancer. Load balancer is routing traffics among multiple API gateways, and those gateways are, you can say, used to load balance, plus like authentication, authorization, some logging, or some microservices rerouting. Over here, we are separating the read and write paths. This is we are doing because, as you can easily understand that Instagram is a read heavy system. It's super read heavy. You can say, like, you create a post probably once a day, but you consume many posts, like 100 or 200 posts in a day. So 1 versus 200, you can say. So it's definitely a read heavy system. So separate these two paths so that write can be scaled independently, and writes which are generally slower, they can be scaled or managed independently. Actually, I have written a small thing over here. Let's actually discuss over here right away. So this is one of the so as I mentioned in the previous lecture as well, that so you need to talk about always trade-offs, and this particular scenario where you'll get these systems, either they're read heavy or write heavy, this comes so frequently. So always remember these tips. These should be in your hand. Okay, if I have a read heavy system, what are different different ways to design a read heavy system versus the write heavy system. Let's quickly go through this thing so that it can be referenced easily in the later case studies as well, and you always remember this thing so that it's easily discussed. So read heavy system, how you can like optimize them. Of course, one is the caching. You, of course, since we need to read the data, you can cache. You should cache. And cache is like, it can be on all layers from the client. Even client can cache a lot of stuff. then load balancer, API gateway, the read, the server, the application server, of course, the database server, the CDN itself is a cache. It stores, static data, your photos, videos, your CSS files, or anything that does not change you CDN. So cache can be at every layer. So which is to to reduce the latency of the read request. Database replication is, as I said, like you make multiple copies of your DB so that you can distribute your read traffic. One scenario could be, oh, you have this write, you can say a primary database and a couple of replicas which are just used for the read traffic. So all the read requests goes to all the read requests, they go to the replicas, whereas the primary gets all the writes. And then you have to handle the consistency, because there are multiple nodes. If whatever is happening to the primary database, it is reflecting in the replicas a little bit later, and that is where the consistency discussion comes, and we say we are fine with eventual consistency. So replication and caching, other thing, CDN we already mentioned, it is used, and they are these edge servers and the main servers, and all these edge servers, they actually have very faster connection with the main server, and they cache data locally and then they distribute it. It's very close to the user. It as compared to the caching is on the server side, or if it's on the client, okay, that is their different part, but all the server side is caching over there. CDN is even a lot more closer to the user. Load balancing is also very, in a way, it senses distribute traffic onto multiple servers, so that one server is not performance bottleneck. It's you distribute, you see the load and divide so your read request becomes efficient as compared to all things going into random servers. Or so load balancer understand the load from servers and distribute load based on that, so the read traffic becomes easy. Data partitioning, as I mentioned, this is very important because if you have more parts, you can read in parallel and the read efficiency increase, as compared to if you have one bigger part, reading from that part can cause many latencies, increased latencies, or many requests going to that, and it can be bottleneck. Optimized data retrieval, we discuss a little. So the data retrieval are your read queries. So you're going to optimize certain set of queries. So you'll see, oh, these are the couple of queries that are very, very frequently used. So have your indexes around them, or have their data cached more, or even you can vertically partition them. Vertical means like horizontal is row wise, but vertical is column wise, you can say. So if a query about a user is always querying like a user and their email or their last login, if these three columns are used by a query, so put those three columns together in one partition, and the remaining column on the other partition. So this way, whenever this query needs to execute, it simply go to this partition where the database has already been reduced to smaller set of columns. So there are a lot of optimization techniques for read heavy, especially the database, that we can use. You can actually read about this thing in the course. If you see the Grokking the System Design interview over there, we have like 4 sections. One is this introduction, then we have the case studies. There's some glossary of basics, and then these are the trade-offs that I keep referring. You can always. So this last one I added actually recently. This discussed all these things that we mentioned in detail with examples of the systems that you can use. Similarly, write heavy. So database optimization. So generally what happens that for write heavy systems, let's say, which is not this system, but write heavy means they have frequent writes coming, not as compared to, uploading a bigger file. No, they have so many writes coming, like like a logging system, you can say. Our logs are coming and they're coming at a very high speed and crazy numbers. Or performance monitoring system, you have these metrics that are coming from thousands of machines and you need to store them. So those kind of systems. So they're these specialized databases that are actually designed for write-heavy systems. For example, Cassandra is famously used. Facebook developed it, yeah. So it's a columnar store. It stores data into multiple columns as compared to multiple rows. So it creates a column for each, you can say a row in the row-based database. So why such systems? There are deeper reasons why those databases are actually efficient for writes, frequent writes. You can actually go read, for example, Cassandra. About Cassandra, I can tell you, for example, at a high level, what I understand is the structure in which they lay down their data. For example, Cassandra uses LSM trees to actually structure the data on the disk, as compared to normal relation databases that uses they use B+ trees. So in general, I think the idea is what they do, they actually have these logging systems, or commit logs they call it. So as soon as you write something, they write it in a sequential log file, and then they accumulate all those transactions in memory, and later they flush it on the disk. So they batch their transactions, as compared to the relation database. If a write comes, it goes in the database all the way to a random location on disk, you can say, based on, of course, B+ trees. But LSM actually, since its writes are coming so much, they actually not do this thing, the commit log, the write ahead log kind of things, and then they buffer everything in the memory, and then they later flush it over here to the disk. So specialized database for write heavies, asynchronous processing that for example, like remember YouTube discussion, you have the video, and then you put the video in a queue. Like as soon as the video is uploaded and a task is added to the queue, you can confirm to the user that, oh, your video is uploaded. So the remaining processing of the video, encoding, decoding, generating thumbnails, etc., happen asynchronously. So asynchronous processing is quite important for write-heavy systems, although read-heavy systems can get benefit from asynchronous processing as well, as we can see over here, or we'll discuss as well. If you see the write means when you have uploaded a photo, so that photo is pushed to a task queue, and then feed generation service is working asynchronously. It a bunch of servers or services instance, and they get the data from the queue. And but for write heavy systems, definitely asynchronous processing is used. Write batching and buffering, the thing that we discussed, batch and buffer, like you have these write ahead logs where sequentially, so what's the issue with straight away writing to the database? Because it goes into the random location, and it needs to be updated into, like, for all the indexes, you can say. But over here, you actually just you write sequentially in a log file, and we call it like write ahead log file, and then buffer all the transaction over there in the memory, and later on we flush it to the disk. And if something goes back, this memory goes away, you have this commit log, and you go back to the commit log and replay those logs to generate the state again and push it to the database. So that's how they do. So sequentially keeping things on disk, and then having a memory buffer is the efficiency that all these databases has been using. Data partitioning, as I mentioned, you can partition, make smaller chunks, so that you can write efficiently into multiple machines together. CQRS, the command query segregation, which we have done over here, but it's mostly like whenever you say CQRS, command means read and write, command query means read and write. So since writes are always heavy as compared to reads, so whenever you want to scale or optimize your reads or writes, then it's always best to segregate these two paths so that they can be managed easily. Event sourcing is a little advanced topic. There's a event sourcing pattern as well in the Grokking the microservice design pattern. You can read over there, but it generally it takes their inspiration from this write ahead logging as well. So what happens instead of so they have these events, and they store the transactions as a set of events, and those events are like sequential, and so whatever the state the database has, they can be reproduced by replaying those events. So that is how they do it. It's again, you can say, as I said, inspiration from the commit log kind of technology. So overall, read heavy versus write heavy, this is something that you're going to encounter in every interview. You'll see, oh, the URL shortening is a read heavy system. All these social network, they are read heavy systems, but logging, monitoring, those kind of system, they are write heavy, and then you have to discuss all these things. This is one of the crucial point, like the SQL versus NoSQL is a little confusing, or it gets very you can say technology specific. If you really have worked with multiple databases, then you understand, but this discussion is something that is generic and more useful, and a lot more expected that you know it, so that you have fixed technologies and you can always use them. Any question over here, thought, comment?
How is data partitioning advantages for read-heavy system, right? So, for instance, if the data is across multiple shards, would it take more time to stitch it all up together and return?
So it depends. For example, let's say you are just streaming a video, so, and you don't jump on watching different parts of the video. You generally see it in a sequence. So streaming is always straightforward, which means, okay, if it's coming from one machine, you already know that, oh, the data is buffering in a sequence and in a constant speed, so you can always cache data. But over there, because of the reliability and availability, means if that server goes down, so you have to make replicas of it, but not partitioning. Partitioning generally helps to minimize overall distribute the load of your reads or writes. For example, there's this one video and you made 3 copies and it's on 3 servers. So many requests come and they get overloaded over there, right? So those 3 machines, as compared to if you have one file and you make like 16 chunks of it and store it onto 16 chunks, then it becomes a lot more faster. Plus your reliability increase like manyfold, and availability.
Yeah, got it. Thanks.
So, yeah, writing is faster. Reading becomes faster too, because you can actually even in the streaming case as well, reading can become, because in the end you are just reading in a sequence. But if you are doing so much random access, like for example, in this case, photos can go into multiple servers very easily. So by the way, when partitioning right now, I'm discussing the horizontal partitioning, where you divide rows. Let's discuss actually right away, because this metadata is already there, and our schema is there too. Where is it? Over here. See, a user and the post are the main things. So how would we, if we want to partition our data, what could be the horizontal partition mechanism over here? Let's say these two entities, and we see, okay, if we try to partition based on user or based on post. Based on user is like we are trying to share, we're trying to see the, okay, one user's data is in one server, one partition, you know. So a user and all of their posts will go in one server, in one partition. So that could be a user ID based partitioning. The other could be where you say, oh, a post is a generic concept. I don't want to like store all the posts of a user on one server. I can distribute based on the post ID. I get the post ID, and then from that ID, I somehow figure out my partitioning scheme that, oh, which partition has this post. So what are the advantages, disadvantages of these two things, and what are those are the things that should be discussed in the interview. For example, in a user case, the famous celebrity user problem can always come, right? A user becomes so hot that everyone wants to read their posts. So the servers, the partitions storing their posts, or they can become hot. We can have caching, we can have the caching is one thing. Further, we can have replicas of for the read traffic, those kind of fixed things that we can do. Any hot post should be cached anyway, unless the cache becomes full, then those partitions can become bottleneck, you know, so many requests coming, or a user creates so many posts that the partition in which we are storing so many posts of that user either is overwhelmed or storage full. It's difficult to imagine this scenario. For example, the metadata is very small, right? If you can say, and posts are not very big as well. But let's imagine you store all the comments of a post too over there, so that becomes so big. It can be so, but right now you can imagine a terabytes of storage data on one partition. So it's very difficult that that a user's data becomes so big that they cannot be fit into a partition. But theoretically, it can be possible. I know Facebook, so the challenge is that in system design interview, whatever the partitioning scheme you are suggesting, you can always discuss these scenarios. Okay, what will happen? Because the read traffic, and then we said the write is so much that so reaching at this stage, or bringing these points for discussion is the most crucial point. Let's say if a user becomes it has so much data because of, let's say, comments, right? So what will happen that it cannot be fit in one server, and okay, there are two discussions. They're interesting two discussions. Although it's getting a little deeper, but it's fun, and it will be used in many other scenarios. One is, let's say you have a shard, you have a partition where you put the data of these certain set of users, and that partition gets full. You came up with the user ID partitioning scheme, and eventually you somehow ended up being the unlucky person, and this particular partition is getting full. What would you do? Anyone has answer to this question?
We will add new servers,
Mhm.
or and we will again divide the partition based on some range or something.
Yeah, like repartitioning, right? So repartitioning is a problem because okay, you create a new node and then move some data over there. You update your partitioning algorithm too. Let's say you have this old way of partitioning where you say, oh, I have 10 servers and I'll take the user ID, modulus it with 10, and I'll find out the server name. Okay, so that is like the old way. No one does it, because as soon as you add the 11th server, this whole partition, every data will be like moved around. So that is crazy. To answer this problem, we have solutions like consistent hashing. I'm not sure if people have read about it, but there are chapters all around in multiple courses. You can always read about it. It's a very, very interesting design. So the thing that you suggested, that's what we do. So generally what happens that within one partition you store multiple, they call it logical partitioning. So let's say you have like 10 partitions, but you just store all these 10 partitions into 2 servers. First 5 over here and first 5 and the second 5 over here. And then okay, the first server is getting full, so you break this one server into 2 servers. So and then you say, so 1 to let's say 3 goes here, remain here, and the 2 and 5 4 and 5 will go to the other way. In this way you're minimizing your data movement when you repartition. So because you only do just the 2 parts of your partition to it. So multiple logical partitioning, you create a huge number of partitioning actually in the beginning. So multiple logical partitioning go into one server, and later when you add a new server, you move some logical partitioning to that new server. So only that part is changed or the data is transferred. So that is what the high level goal of consistent hashing. So again, in this scenario, again, if this thing happens, if you have not made a bad mistake of that modulus based, sharding or some other very basic sharding things, then you are stuck. You ended up moving. You have to. There are solutions, because all those legacy systems with which were built at that time, they did not foresee the scale they're gonna meet, so they are bad partitioning scheme, and they ended up adding more layers to manage all the partitioning. Then Facebook has it. Facebook ad system had that. I know that. But anyway, so the answer to the question is this logical partitioning you have to think about, and if the multiple users getting into one shard and that shard getting full, then you move some users to another partition, and your partitioning algorithm remains the same, because now you just change one setting, that okay, first 1 to 5 was on this server, now 1 to 3 are on this server, and the 4 to 5 are only on the other server. So just one, generally a config change all over the nodes. It's a distribute. There's no like main server in consistent hashing. All server knows the partitioning. All server know all the partitioning of all other servers. So, yeah. Any question?
You said look up consistent hashing, and that's kind of see how that's being used, and that helps answer the question.
Yes. Eventually, whatever I was like trying to tell is the high level view of consistent hashing. Multiple logical partitioning into one server, and later when that server gets full, you actually create a new server and move some of the logical partitioning to over there. And so this actually answers our question, in which there's this one server, one partition where these users are there, and it gets full because the user have created so much posts. So means how we solve it, we move some data to another partition. It's a repartitioning mechanism, but your algorithm stays the same, and you just have one config because of the new server. But eventually what can happen that let's say you have gone such big, or a user has now this is a little theoretical discussion. Let me ask this question to everyone, if anyone knows this answer to this question, that you actually keep adding more servers and moving the users to these new servers. And eventually, theoretically, you reach in this scenario there where one user is being served by one partition because the users have gone so big. So let's say one server is serving this user, this big celebrity, and we cannot actually fit the data of that user in one server. I mean, it's difficult to happen, but it can happen theoretically at least. So what can we do in this scenario?
Can you partition based on like location? I don't know if that would help.
The partitioning scheme is the user, right? You are distributing data based on user. So if that user and all their post has to go to this partition, there's no, unless, I mean, if you repartition based on, let's say, anything, the age or location, that is altogether a different system. So unfortunately, we ended up using our user ID as a partitioning scheme, and we never foresee that, okay, this will happen, but if it happens,
What about,
Hmm.
sorry, what about vertical scaling just for that one user?
Yeah. See, that's a good answer probably, because you can move some columns to another partition, and then we can have a layer which redirects the queries based on, or if we have to join as well, you have to do it. It becomes slower, those joins, which needs column from from the two partitions. But most of your queries could be faster because you intelligently do that. Theoretically, I can say even this thing can. Again, like
Yeah.
in the end, you can have one column, right? Or two columns, ID and one column, and that partition can theoretically becomes expensive. It becomes full. So anyway, so what happens that let's say Facebook is 10 years or 20 years old system, and the things can happen there. So what happens that they store everything that you have posted on Facebook. Facebook has all of your history. Any photo that you uploaded 15 years ago, it's still there. So what they do, they keep all the they take all the old data and move it to another storage, like cold storage they call it, or some like a storage that is very slow and that is hardly accessed. So for example, your recent data, few weeks, few months data, or a year's data is there in the main storage, but all the older data goes into the cold storage. So this partition becomes happy again. The data is still there. If you want to access it, it becomes be a lot slower. If I mean, for example, if you just go to your Facebook and try to see your 12 years, 15 years old photos, it will take a lot of time. Sometime even hours, because they have to go and see. That's what I remember. But anyway, so that is how you move your cold data as compared to the hot data or warm data. These spectrum of the data, hot or hottest data, or very fresh data. You have to put it in the cache and then storage, then the warm storage, and then the cold storage. And so all these bigger companies, they have all these storage systems. Glacier, which is Amazon's cold storage. A lot of this data they have to store because of the security reasons as well, or the audit kind of stuff, So and then they have to then because of this privacy and all these reasons, somehow they have to delete it all the way. It takes some time, like a few days to delete your data from all the way to their systems. But because of privacy, I was part of that team that was devising this thing, and it becomes crazy because the data is distributed in so many places in so many different ways, and as the systems evolve, they do that. But I mean, anyway, that is the answer.
So changing the like, I guess adding, like you said, adding a different storage based on like an S3 class.
Yes.
So for stuff that's used often or like newer, you have a better, I guess, S3 class, and then you use as the older stuff goes into like a different class. That's all.
Yeah. So for example, I'm a startup. I started today, and 10 years down the road, I'm still like using S3, let's say, and I figured out this scenario. Then I bought the cheaper cold storage, moved. Then I have to write this layer where which can take the request of the cold data and then actually fetch it from there over there and serve it from there either, or bring it back in the warm storage part and then serve it to the user. Yeah, that's the overall answer. So it's a theoretical answer, but this discussion is relevant to so many, scenarios where you can actually theoretically go all the way down, and then you can discuss things.
Hey, Arsan.
Yeah.
What is the,
So will it be,
yeah, please go ahead. I'll ask again.
Yeah. Okay. Victor, go.
yeah, so in this case, I mean, would it be worth talking about like, I mean, I don't know if it's practical to have two kinds of systems, one for like normal users, another for like power users, like celebrities, for example. But like I've heard that mentioned before, like I mean, normally you have those at the end of the tail, basically. So you want to account for those. I don't know if that's worth like having a second system or just like updating the current system.
Yeah, so what I'm trying to actually explain is it's like the same data, but you always keep moving your older data into a colder system because a backup or backup storage, and then your application layer understand this thing, let's say, because you say, okay, your main metadata servers, they have only a couple of years of data. So they have, for example, a configuration somewhere stored that, or from this day or the a particular date before that data, it's on the other storage. They go on to that storage and serve the request. So it could be the same one layer that understand that the colder data is in another storage and your warmer data is in another storage. And it can only be applied to the hot users, or like the user which has a lot of data. Did I answer your question?
Yeah, you did. Thanks.
Okay. Yeah, Karthik.
Yeah. So what was the solution you were saying for the celebrity? Like, do you suggest using vertical partitioning, or is there any other solution that you were telling?
So celebrity user has like the first issue was, oh, the celebrity user means they have so many followers. So they made a post, and so that post needs to be cached, because otherwise it's gonna bottleneck the partition on which that post is going, right? Because there's so many people wants to read that, we notify them, or that post goes into the newsfeed of everybody. So that is the celebrity user problem. Read-wise or write-wise, they have a long history and they create so many posts. They have so much. So the data in which the partition in which their data is stored, it can become a bottleneck, and it can affect the read and writes of the other users that are stored on this partition. For example, like you are the celebrity, your posts are going into those partition, but the other users that are going to that partition too, they become slower because of you, the availability is reduced, the latency is increased. So those were the two problems, and the solutions were all these things that we discussed. Either we have replicas, you cache, and all this thing, and then you partition your data this way that you can actually smartly optimize your reads and writes. Did I answer your question? Okay.
Yes.
Okay.
Thank you.
Yeah. All right. Anything else? Otherwise, we can actually discuss a couple of other things in this diagram. Where did I say user and pools? Yeah. So the other thing is for example, the write over here, you come over here, you store it in the blob storage, and they cached in the CDNs because the content never changes. And also you put a task in this queue, and then these set of feed generation services, you can say they take the task from the queue and generate the news feed. News feeds is all about metadata, you can say. So what could be the brute force algorithm? So I'm a user and I follow these 100 people. So the news feeds with generation what will it do? It actually goes to the database, get all my get all the people that I follow, and take their let's say latest posts, rank them using some algorithms, some other inputs from a recommendation engine or something. So rank, filter, do some fancy thing, generate, let's say 200 posts for my news feed, and put it in the database. Okay, so in the database I have this news feed table, you can assume, which has the chronological ordering of those 200 posts. And then when the user wants to see the news feed, it goes all the way to the news feed table and show me all the posts. This could be a brute force kind of an algorithm. So if a new post come that get pushed, like one of the person that I follow, they created a post that went into the task queue, the feed generation take that post and see all the following of this post, and based on certain parameters, push this new post to the news feed of all those people. That could be the most brute force algorithm of the news feed. But I mean, practically this never happens. Because it's very slow. Like for example, like if I open my Instagram app on my phone, if it has to do all these things, like okay, generate my news feed, do it over here in the storage, and then it goes to the client, it's very slow. So this pre-calculation of the news feed that we discussed, at least this we can do. And instead of storing into the you can say the storage, the database storage, we can actually have a separate cache for just the news feed, because you can imagine in the news feed has just a set of IDs, which is just the post IDs that are shown in that ordering. Then how would you update that thing? For example, in Instagram or any social media, you have this news feed and you see like 20-30 posts, and then you close the app, so you don't see those posts again, which means it in cache, when you're storing it, you have to understand this thing and devise some algorithm to take care of this thing. You can have a linked list kind of a data structure, the way you do it in LRU cache, the least recently used cache. If you guys have seen the algorithm for it, it's like it's a linked list, and anything that is most hot, it becomes at the head of the linked list, and the linked list is that order of posts that you can show. So if you have seen the first 30 posts, they'll just remove them from the linked list, and in the cache and then wait for the new entries to come based on the people I follow. So or you can move the post in the linked list in LRU cache as well. So if a post becomes hot because there are new likes coming or commenting, or so the algorithm decides to show that post again, or increase the rank of the post, they can go into the cache in that linked list and actually move that post to the higher based on that sorting, that algorithm. So overall, there are these surveys which is taking feed generation surveys, which is taking so many inputs, all the rights or even likes or commenting, sharing, or anything that everything goes in this task queue. They take it and then they update the news feed of all the relevant users based on the interaction or the hotness that we are getting for each post. So that is just the generation part. Any question or comment around this thing? So one other aspect is how would you show this generation, this news feed to the user? Like in Instagram. So these days, there are these pull-based, push-based models, right? Either the server push the data to the client or the client pulls the data. For example, on my now you don't see a scenario where you're watching your news feed, you're seeing your news feed, and suddenly everything refreshes. It never happens, right? But in older times, I used to remember Facebook does that too. Did it too. But now you're seeing as soon as their new post, either the app notifies you a number account or their new post, there's the small banner at the top or account somewhere showing their new post in your feed, and you pull down the phone or like refresh it on your browser on the desktop. So at that point, the data is fetched. So what happens that these feed generation service, they need to notify the current active users then somehow. So all these active users, they are having a live connection with one of the servers. So then we need to actually develop this mechanism that the feed generation service, when they added new items to a news feed of a certain user, they have to find out the server on which this user has made a connection and tell this user, oh, please pass this message to this user that they have new posts as well. Which you can say like, okay, connection pooling is there, or somehow you have to devise a mechanism to figure out which app server has a live connection for the user. Like when you open the app, for example, in your phone, you can assume you have a WebSocket kind of connection with the server, and you're constantly like communicating with the server. Whatever the interactions you're doing, you're updating, commenting, liking things, the data is always going to the server and getting stored and reflected into other posts. And similarly, the server is also passing the data back to you, or their new posts or stuff like that, or new message has arrived. One is this in-app notification, and then there's this, you can say offline thing. When I'm offline and I have subscribed to these people, and I have, I don't know, Instagram, but all these people have all these other apps, they have the notification thing. If I click on the bell icon, they'll notify me even if I'm not online. So that is a push notification. That is another kind of mechanism, which again feed generation service needs to know that, oh, there's no live connection to this user, so please pass it to the notification push notification system, which pushes it to a different mechanism. Like the way the push notification comes to your it's a notification on your phone, and then you open it, and then the app opens and you open that post, stuff like that. All right, any question or thought?
Just one question.
Yeah.
So for designing the system, just like is there like a rule of thumb, like in terms of like how many CDNs one needs? Like the number of like well, yeah, basically how many CDNs one needs for a given system?
I don't have any expertise around here. So what happens that so the Facebook and all these people have their own networks, or somehow they also use. But for example, Netflix has to stream, and they use, like, I think they a couple of famous CDN systems. So Akamai, and so they have edge servers all over the world, and then they based on certain loads, they auto scale and stuff, and they take data, and they're responsible with. So that is very complex model. I don't have any understanding how this works and how do they scale, but generally it's a very expensive thing. So only bigger players, there are 2-3 big players with CDNs all over the world, and then all these big companies like Amazon, Facebook, they have their own origin servers, they call it. Origin server is the main server that has the data. So you can have multiple origin servers. So you have your own, for example, Facebook is here, but they have a for the Asian traffic, they have a origin server in Singapore. And from those Singapore servers, they're using actually an edge network, a CDN network of Akamai, which is pushing data to, let's say, India and all that region, or China and everywhere. So these bigger players, they are responsible to send to push their data to the origin servers, and from their origin servers, it goes to either the CDN's origin servers or the edge servers directly. Even they can have their own. Facebook does have their own edge server kind of mechanism. But how many you need, I don't know. It's like it's scale and auto scaling, and it depends, I guess, how much load we have, and so yeah. So right now, these Akamai and all these, they have so much data. They understand the traffic. Netflix is launching a new TV series or a movie or any big concert kind of things being streamed. They already have a lot of data, so they scale automatically, and all these things are generally now not a person's hand. It's mostly like algorithms and little bit and intervention that they scale automatically, and start caching more data and serving it, and more replicas and stuff like that.
Oh,
Got
this
it.
is,
Thank you.
sorry, this is Imran. I have, if you can a little bit elaborate on this one, that is the better system design can reduce the need of CDNs? Because I was thinking that CDN are just caching on a edge locations, whatever the data. So does the better system design play any role in that?
So CDN is the fastest cache, you can say, because it is the closest to the customer, the user, because that is what the infrastructure is. So CDN says, oh, you are American based company, but your CDN servers are in Singapore or like in Middle East, somewhere in UAE, right? So you have to get closer to the user to reduce the latency. So over there, you cannot have like your dynamic data, but your static data, images, photos, CSS files, some JavaScript file, I guess, too. They can be over there. Did I answer your question?
Yeah. So, because I was thinking that as you are mentioning that it's not like dynamic, it's all static.
Yeah.
So I was just thinking if the system a system is designed properly, or if there is a system which is not the components are not designed properly. So in both cases you are using CDN. So
Mhm.
there will be cache. So I was thinking that algorithm or strategies, or you are already, I think, mentioning, but I was just thinking that if you can elaborate on that, I think you did that, if you design your system more efficient way, so then maybe you can decrease some load on a CDN, or you may not be relying heavily on a CDNs,
Hmm. Yeah.
or
So
you
it's
can.
yeah. So it's a cache. So you are reducing load on your main servers, and they are just serving data. Imagine Netflix, right? So they cannot really have no solution other than caching, and caching as closer to the user as possible, which is CDN. That is the infrastructure they have invested on, um, and you cannot. It's just like you are on AT&T over here, but if you go to China and you use a network over here somehow which has AT&T available over here, so AT&T is not available. You are just using the infrastructure of some local telecommunication thing over there. So similarly, Facebook or Netflix, they cannot have this bigger cache distributed all over the world. So go with the bigger players. You can have certain set. I mean, if you go big like Amazon, right? S3 and all these, they're so big. They have a lot of their CDN kind of things. and it's a costly solution as well. If you start configuring, it becomes costly, but I mean that's the user experience different services wanted to offer. Yeah, go ahead. You may not work on all the technical components like queue or notification server, but we might work individual components in smaller projects. I'm just reading comments. Okay. Would you talk about envelope, the back of the envelope estimation? Yeah, we did not discuss that. So back of the envelope calculation, I like to do it whenever it is required. I don't want to do it right away because it might waste your time, a lot of time, and you might not use them at all. Over here, we understood that our system is big, so we know we need to shard, partition our data. We have so much read-write requests. And if you see the original chapter over here, designing Instagram, it does calculate actually. So there's this high level of calculation, capacity and constraint. We say 500, half a billion users, 1 million active daily users. It's just the numbers they assumed, and the photos and how many photos per second and what the size of the photo. So how much storage you need, and for 10 years we need like 1.4 exabytes, and then data size. They did the estimate, estimation later on. They take all the columns of the user, and this is the size, the payload of one user, and for 500 million users, you can assume 32 GB of data. This is the metadata of the users, just 32 GB. Similarly, for photos, they said, okay, we are getting half GB per day. For user follower table, user follow table, we have 5 million users, 500 followers, each user 8 byte, so 1.8 terabyte. Overall, if you combine all of these numbers, you get 3.7 terabytes, which is not at all comprehensive. You can assume a lot more data now, exabytes of data. So, but this calculation tells us the size, and then based on that size, you can always you can either see, for example, from the storage, you can say, okay, how much storage you need, and how you definitely need to partition your in this case, just the metadata we are talking about. By the way, the photos over here does not mean the actual photo data, because it has ID, user ID or stuff. It's just the metadata. And if you add comments, this gets crazy. This terabytes becomes exa or peta or whatever the petabytes are there. So for example, this kind of a system, we already know it's too huge. We don't really need, we can straight away go over here. If we really want to understand, let's say, what's the bandwidth we need, we can calculate, but again, you can assume they're like 500,000 or more than 1 billion users. You can try to estimate, but eventually it would be in terabytes of data, network inflow, influx or outflux, and then what would you do with those numbers? You can say, okay, this is anyway too big of a system. So you're gonna, I mean, in an interview setting, you can scale. You can have multiple servers. Over here, I think the more appropriate discussion is discussing your partitioning mechanisms, your single point of failures, how would you remedy them, how you optimize your read queries, because it's a read heavy system, stuff like that. The news feed generation system, the algorithm becomes tricky over there. We have a separate, by the way, problem in the chapter. This is the Instagram. Where is the news federation? This one. Facebook news federation, news feed generation. You can actually go read all this thing. I think we discussed a little bit, but for a detailed discussion, you can actually go. It discussed this algorithm actually that I was trying to reference. Yeah. So we're not gonna discuss that system design anyway, because we touched upon it. But if you guys have any question, you can always ask a question on the Discord channel, or even in the next lecture when we're gonna discuss this thing. Yeah. Anything else? Otherwise, we can dig deeper into a few other topics. As I mentioned in the beginning, all these systems are like this. So a lot of the discussion we had here, it is valid to many other systems. Okay. So what else we can discuss? So load balancer and API gateway, they're easier ones, right? A lot of people, they always get confused. Oh, load API gateways are also balancing load, so why we need load balancer, or do we want to put load balancer behind API gateway or after API gateway? So load balancer, you can say, is more crude, and it's mostly balancing the load based on certain numbers from certain performance metrics from the servers on which it's trying to balance the load. So it has 10 servers in front of it, and it has some performance metric, how many connections each server has, how much, latency or throughput or anything, and based on that, it can load balance, right? So and then generally most of the systems, they have their first point of entry is load balancer, and then over there you can have your security mechanism implemented and stuff like that, DDoS and other attacks, and then it balances the load to the API gateway. So the API gateway is not single point of failure. This, which means load balancer is a single point of failure, and that you do, I don't know, we discussed last time, you can have a standby load balancer, and those two load balancers they can be a daemon running on both the servers, and they can watching each other. If one server is down, the other takes control by changing the DNS entry, so that all the traffic now start going to this load balancer and stuff like that. So this is the first point of entry, some basic stuff done over here, but mostly routing and based on the load. API gateways, they are more smarter. They're routing your traffic from the read-write paths, separate paths, or they can do certain stuff, authentication, authorization, some logging, some API calling, merging request, or their multiple version of the APIs are running. So they transform the data from the older versions and calling the newer versions, and then then the response getting from the server, and reevaluating that response and changing it, morphing it back to the original format, sending it back, stuff like that. Or even these days we have cloud-based serverless functions, so serverless functions are, essentially they run on a server. It means you don't worry about servers. So it's cloud-based. You have just a piece of code, and you tell in the cloud that, oh, whenever I call this endpoint, please execute this code. So that is, and run it anywhere. I don't care, just scale, and whenever I need, it should be highly available and fault tolerant, stuff like that. So API gateways can actually just call. They can orchestrate. This is the step of API call they need to do. For example, these are the serverless function. This is the final server, local server I have to call, and then accumulate the result and send back to the user. They can cache a lot of data over here too. So I'm just taking a point to discuss these two because they keep coming, and probably we're not going to discuss them in other case studies. But you can actually have a load balancer after API gateways too. Or anywhere, like even between metadata and app servers too. There's a load balancer, and it understands the load on the databases, and based on that, right now it's for example directly going to the cache. So every read request goes to the cache, and the cache is responsible to either fetch the data from the database or return it If there's no data is a cache hit, then it has to read from the metadata and return it. CDN is another, is as I said, a cache. You can have a separate distributed cache as well. Like this is a separate distributed cache, you can say. A server, a separate server, which is caching everything. So it's a distributed, it can have multiple servers, or but then each layer has their own cache. Metadata has their own cache on that server, which is called query cache, or there are other names to it too. App server has the cache for requests, a request that is always coming for a post, or if you have the data of that post, you can actually return it from local cache as compared to going to the Redis cache. Yeah. In the chapter, we did have some discussion about the recency that I talked about. So the ID we have that we discussed in the post. In the newsfeed, if you assume that you're gonna always access recent posts most of the times, you can you can have two things. One is add a secondary index on the creation date. The other is creation date or update date or whatever the latest date you have. Or the other is make your post ID time agnostic, you can say. So you can do the current time, the epoch time, let's say, which is a number, and then append a sequence number to it to make it unique all over the world, all over the system. In this way, you can use the same ID to fetch the latest posts. So you are combining the epoch time and the unique identification of the post into one key, and then only have one index on that key. The chapter actually discussed this scheme. This is especially, relevant if you are sharding your post database based on the post ID actually. By the way, you can shard each table separately. So in this case, if we are sharding based on the user ID and we say a post, all the posts can go to the same partition where that user is. But if you say, oh, I'll partition users based on, let's say, location, and then post ID based on their ID. So which means users of, let's say, America, they all go to one server, or like certain partitions, or zip code based partitioning, whereas the posts are distributed all over based on the ID on any server. So if you have to read a post from that ID, which is unique across the whole system, epoch ID, and then that sequence number, which should generate a unique sequence number for any post that you are generating, and make it unique all over the system, store it everywhere, and from that ID you can fetch it on that from any particular server. So that is a smarter way. We also, I think, discussed it in the Twitter chapter or somewhere where this becomes more important. One of the, I think it was like I originally read it in one of the blog from probably either Instagram or somewhere. They used actually this thing where they added the epoch time to the ID itself and make it unique, so that the recency thing, they don't have to have another secondary index. The primary index is sufficient, and that's fulfilled in most of their cases. All right. If you guys have any question, otherwise, I think we are done over here.
I have a small generic question.
Yeah.
Is it good to start with a high level design for a system design interview, or where to start when in a overall interview process? So should we right away start with high level design or estimation? What do you suggest?
Yeah. So again, there's no clear answer, but my recommendation is don't do estimation unless it's really needed in the beginning. You don't really understand. For example, if you read the chapter the type head suggestion system, right? The type head system where like Google suggest and all that. So over there, we try to estimate the data, and we figure out, oh, this data is not huge. It can easily be served in one machine. So we figured out, we found some data from the calculation. So don't do it until you reach that point where you really felt, okay, now I don't understand how many servers I need, how many bandwidth, whatever, and then you calculate. Always jump to either the high level design or the API design. We did not discuss API design over here, but certain systems, let's say you're designing a key value store, right? So over there, you have just 2-3 operations. You put a key and their value in the database, or you get a key, or you, let's say, delete a key, let's say. So these 3 things are very important. So over there, it looked like probably the system high level architecture is very small. So, but these 3 APIs could be crucial. So you actually went with API. So either with the API design or with the high level architecture. My general suggestion is go with the high level architecture. These 6-7 blocks you can always draw so quickly. In system design interview, or my recommendation is always go breadth wise easy in the beginning, and then go deeper. When you have the whole breadth easily shown in a diagram, then you have at least conquered a bigger part of the problem, that the interview really understand, okay, you have the whole picture in mind. It's not that you just expertise in particular area and you're just trying to focus on that area. So give breadth, always give breadth, and to give breadth in the beginning is always possible through high level architecture diagram with 7-8 blocks, you can say, and then dig deeper with the database. So over here, it was clear that these things, for example, this thing really derived a lot of discussion, if you really know, if you remember our discussion. So yeah, I guess these 2 things, and then you can always start digging deeper over here and collaborate with the interview to see where the discussion is going on.
Okay, and one follow-up question. What does interviewer really looks from a senior engineer versus staff engineer versus principal engineer? So where do they actually differentiate between senior, staff, and principal? Because it is the same concept. Maybe a senior also can explain, a staff also can explain. But what else we need to show if at all I want to apply for a staff or a principal?
So look at this blog. This is although it's written for FANGs, but FANG company, but it's valid for the other things. So if you see software engineers, what is required from them, and then senior software engineer discussing trade-offs, and the principal software engineer. Let's start with the principal or principal plus engineers. So strategic technical leadership, that's what I said. So you have to vision your product at a high scale. Remember this thing, the WeChat, the China's WeChat. It started with a chat app, but now it looked like it's running the whole country. It was a chat thing, but then video, audio chat come to it, and then payment came to it. Your doctor appointments come to it, and then your COVID, vaccine, or even COVID control, the red zone, all those things came to it. So when you vision a product to a global level, that is what is expected for principal level engineers, right? Overall, the cross-functional collaboration, the complex problem solving, I say, mentorship and influence, like when we discuss, when you present trade-offs or when you have communication with them, with the interviewer, then you really understand, okay, then they can evaluate you, okay, whatever you're suggesting, what are your influencing points. If you disagree with someone, then they have to bring points to to justify their design. So all those discussions, it becomes more mature, and they take the product to the next level. Most of the things from the senior engineers is they have to lead the discussion. So as it said, focusing on your technical abilities, but also your leadership and strategic thinking. Expect discussion around past projects. That is generic things, scenarios to show up. But generally you have to lead discussion, which means you actually come up with all the important requirements, and at every stage you have these things in mind. You have like, okay, is it batch processing or stream processing? Okay, is it for example, if you have worked with REST or gRPC, right? So you really know, okay, over here it's a simple REST based protocol, but if you need more sophisticated filtering of the data or more focused data, you go with gRPC or the other fancy APIs. So again, it's all about trade-offs and how you present. For a junior engineer, probably they don't understand a lot of this stuff. They might know, okay, stateful or stateless, but they might have only worked with like, let's say, stateful architecture or mostly stateless architecture. But you really understand that, oh, in lot scenarios, we need actually stateful, and how that statefulness is impacting the design. So lead the discussion and present trade-offs. And for principal level engineer, go beyond, go global, go high scale, or you have to show that, oh, this thing can cover many things. Probably, I think, I hope I can actually paste that link over here in the chat. Right.
Sure, it helps. Thank you very much.
All right, cool. All right. Thanks a lot. I'll see you next time. All right, bye.